Now let us see the secondary cells. The secondary cells are those cells which can be recharged again once they are used. In this, what we do is that when we are doing the recharging of these cells, the electrolytes consumed are again basically are regenerated back along with the electrodes. So all the matter which is actually was undergoing the reaction during the use were getting regenerated and they are actually being recharged. And the speciality of therefore the secondary cells is that they can be reused again and again because they can be recharged again. The most important type of the secondary cell is the lead acid battery or lead acid cell, which we use in our normal day-to-day life all around around us. Like the lead acid battery is the one which is also used in your cars, in your bike. The emergency lights are the cells which they are having is basically are the lead acid batteries. The ones which we are using in the bus or in the trucks, all basically in your inverters, like all these are the examples of the lead acid batteries. Now in the lead acid batteries, each cell gives a voltage output of 2 volts. And if we can count at how many cells a battery is having, if it is having 6, the batteries will be of 12 volt. Now let us see a reaction which is taking place in each cell. Now the anode of the lead acid batteries is made up of lead and the cathode is made up of lead oxide. The electrolyte used is common for both and it is sulfuric acid with a specific gravity of 1.38 grams per cc, which is 38% by mass. Now what happens during the use during discharging? So this is the reaction which is happening when we are using it. We call it discharging. That what the anode, at anode what we find is lead combines with the sulfate and forms lead sulfate and gets oxidized and releases 2 electrons. Now these electrons then they comes back to cathode. Lead oxide in presence of H plus ions and sulfate ions accept these electrons and gets reduced from +4 state of lead oxide to lead sulfate and forms water. So the electron gets cancelled. The overall reaction is lead plus lead oxide plus 4H plus 2 sulfate gives you twice of lead sulfate and water. So after the use, both the cathode and the anode gets converted to lead sulfate and water is formed. See what happens. As the water is produced and the main electrolyte, the H ions and sulfate ions are getting consumed, the cell or the battery shows a potential drop. And what happens is, since the density, no more of the water is increased, the density of the sulfuric acid decreases. So the potential drop takes place. Now if it reaches beyond a certain limit, like when it reaches to about approximately a value of 1.20, the potential drop is so large that once it is connected to the inverter, the inverter shows that the cell or the battery is not able to perform to its full strength and it is to be now recharged, and the inverter cuts your circuit and then the battery and the cell needs recharging. Now when we do the recharging, what happens is the external source, basically the AC gets converted into DC and which is connected to this one. Then during the recharging, your anode becomes your cathode and your cathode becomes your anode, and just the reverse reaction takes place. Same reactions. So that what happens is all of these lead sulfate which was formed at the electrodes gets converted to respective lead and lead oxide. And the water formed, which has decreases the density of the sulfuric acid, is consumed. Again sulfuric acid is formed, and that is why density again rises, potential drop, there will be again increase in the potential, and once it becomes more than the one which is being applied from outside, the circuit gets disconnected, and then we say that the cell of the battery is completely charged. So this is how this lead acid battery functions. The next type of the secondary cell is the nickel cadmium cell. It is the one which is normally we see are used by the photographers for their cameras. They are recharged again and again. These are the same times which are used in your toys also, which are actually rechargeable having cells. So these are your normal pencil type rechargeable cells, which are actually nickel cadmium cells. In this we have basically the anode of cadmium, which gets oxidized to cadmium oxide, and the cathode of nickel hydroxide, which gets reduced from +3 state to +2 state. So the reaction is cadmium reacts with nickel hydroxide, the the electrolyte in this is your OH minus ions, and it gets changed to cadmium oxide, and the oxidized, and the nickel hydroxide gets reduced to nickel hydroxide, which is there in the +2 state, and the water is formed in this. When this is the reaction which is taking place when we are actually using the cell, we call it discharging. When we actually recharge it again, what happens is this water which is formed gets consumed again, the cadmium oxide gets further oxidized to cadmium, nickel gets reduced, to this one cadmium, and the nickel hydroxide gets oxidized to nickel hydroxide in +3 state. So it gets back, water gets consumed, and this is how this cell can be reused again and again.